All right, problem 6-127. Ryan has the chicken pox. He was told that the number of pock marks on his body would grow exponentially until his body overcomes the illness. He found that he had 60 pock marks on November 1st, and by November 3rd, the number had grown to 135. To find out when the first pock mark appeared, he will need to find the exponential function that will model the number of pock marks based on the day. So letter A. Ryan decides to find the exponential function that passes through the points 3, 135 and the point 160. Use these points to write the equation of his function of the form f of x equals a times b to the power of x. Let's just remember here that f of x equals ab to the x, same thing as saying y equals a times b to the power of x. Since we're dealing with points here, I think sometimes it's easier for some people to see what we're plugging in if we think about the input and the output in terms of x and y instead of just f of x and x. Our 2 points that were given are 3, 135 and 160. And we're going to use those 2 points to find the function in this form. Now, the fact that we've been given 2 points is going to help us because each of these points has an x value and a y value. So we're going to need to solve for our values of a and b. Since there's 2 unknown values, we're going to have to use 2 equations in order to determine what those values are going to be. So let's start out here by just substituting in what we know. So if y and x will make it true, if this point is on the function, when we plug in 135 for y, it should equal a times b to the 3rd power. We're just simply putting in our 3 for our value of x. The second equation we'll use is going to be the 160, so 60 is our y, and then that equals a times b to the 1st power. Now we're going to solve it. There's a couple methods for solving these kinds of systems. I'm just going to do one of the more universal methods, and that's just substitution. I'm going to take one of these variables and isolate it, and then plug the expression that I get for that into the other equation for that variable. So for instance, let's look, 60 equals a times b, because b to the 1st is just b. I'm going to isolate a here, so I'm going to divide each side by b. So right now I know that 60 divided by b is going to equal a. Now that we know that 60 divided by b equals our a, let's use this equation and substitute in our expression for a. So 135 equals, instead of a, we're going to put in 60 over b. And we'll be multiplying that by b to the 3rd. Now when we try to simplify this side, we're going to have our 135 still left on the other side, but 60 times b to the 3rd divided by b would be 60b squared. To undo the 60 times b squared, we're going to divide it by 60. And 60 goes into 135 2 1/4 times, or we could say 2.25. And then our 60s here will simplify to give us 1, so we have b squared equals 2.25. And since I'm kind of out of space there, I'm just going to move it over. I'm going to say 2.25. If that equals b squared, we can take the square root of each side to figure out what b is going to be. And we'll see here that the square root of 225 is 15. So the square root of 2.25 should be 1.5. Square root of b squared in the context of this problem should be just b. So now we know that b is going to equal 1.5. That is our rate of change. Now we need to go back and figure out what a is going to be, and we can just substitute our value in to find it. So let's do that. We've got b equals 1.5. I'm going to take it, and it probably looks like it'd be easier to plug it into this equation instead of this one. So we're going to do 60 is going to equal a times 1.5. You could have 1.5a. I'm going to divide each side by 1.5. And I'm sorry, that was to the first power, so 1.5 to the first power is still just 1.5. And I'm going to divide this side by 1.5. Now 60 divided by 15 would be 4. So we're going to have to adjust it here, adjust our decimal. So we should get 40 is going to equal a. So now we've come up with the values of our two parameters, our a and our b. And we can write out our equation, and I'm going to change it to f of x since that's what it's asking for. We're going to say that f of x equals a, which is 40, times our 1.5, or 1.5, to the power of x. That's our equation for part A. Now we're going to jump into part B here, which says, according to your model, what day did Ryan get his first chickenpox pockmark? So as we think about this, I'll change to red so you can kind of see the difference here. I might be able to just kind of squeeze it all in here on the right. We'll see. So for letter B, we want to know, when did he get his first chickenpox pockmark? So that, when you think about our ordered pairs, our x values were the number of days that are going by, and y is the number of pockmarks. So as we look to solve this, we're going to want to solve for x when our y value is 1, or when there's 1 pockmark. So we can use this equation to help us solve for that. We don't know what x is, but we know that whatever x is here, our f of x should have to equal 1. So we're going to substitute 1 in here. We're going to say 1 equals 40 times 1.5, or 1.5, to the power of x. And now we're going to solve it for x. So let's divide each side by 40. So 1/40 equals 1.5 to the power of x. Now we need to solve it, so let's go ahead, and since our x is in the exponent, because it's an exponential equation, let's take the log of each side. I have the log of 1/40 equals the log of 1.5 to the power of x. And we can use that power property of logarithms, which will move our exponent from in here to becoming kind of like the coefficient of our log. So we've got x times the log of 1.5. Remember, that's the power property. You need to make sure you know that one. And that equals the log of 1/40. And then to get x by itself, we're going to divide each side by our log of 1.5. So let's see, we're kind of Running out of space there, but I probably will need my calculator back up here, so let me figure out where that went. There it is. Let's go back to full screen. Alright, I don't know why that keeps writing when I don't want it to. Alright, just slide this over a notch there. Now we should be pretty good. I go just a little bit farther so I can reread the problem. So we know when he got his first pock mark. So if we do here, x will equal the log of 1/40th divided by the log of 1.5. I'm going to do that on the calculator. So the log is 1 divided by 40 divided by the log of 1.5 gives us x is about -9. So x is approximately -9. So what does that mean in terms of the number of days? Well, if you have -9 days, that means we're going to have to go back 9 days from where we're starting. So if we go back 9 days from our November 1st, where we had it measured there, we should end up being about, what would that be, about October 22nd or so. So we can then say that Ryan got his first pockmark back around, yeah, let's say probably about October 22nd. Remember, x is -9. It's the number of days that have gone by since he went and got counted all his pockmarks. So that is it right there for this problem. We're on 6-127. If you have additional questions, please make sure you ask your teacher. Otherwise, I appreciate you watching and looking to get some extra help. Good luck.